part 3 of section 4.2. We left off last time with just setting this up in part C, using our model from part B that used the value we found in part A. So now, if you thought about this at all, it's like, how the heck do you solve for t? It's in a power. And if it was being multiplied by something, you could divide. If it was being, something was dividing into it, you could multiply. If it is being added or subtracted from something or to something, you could use addition or subtraction to get t alone. But now with this power, it's like, how do you do that? And in this class, we are going to use something that we won't really use any other place. And that's why we're not going to go into it too deep. But there's this thing in math called a logarithm. And a logarithm is related to the exponential function in that it's what's called an inverse of it. So we won't do a whole lot with logarithms. If you're going to go into an algebra class, you'd see logarithms a lot more. You would see more things with the functions, more properties of them, all this stuff. But we're going to use it for the one thing that's really important about logarithms, this one property that it has, and a beautiful property, and one of the most useful properties, is that when you have a logarithm of something that has a power, you can move that power down in front of the logarithm as a product, multiplication, which we can then use division to undo. So what we're going to do here, in order for this to work, you have to get this alone first. It makes things so much easier. Technically, you could do it without it, but I always say you got to do it because it just makes things easier. So we're going to get this parentheses stuff with the 1 plus rate alone by dividing by 5,000 on both sides, since 5,000 was being multiplied by it. And that'll give us 1.37 to the t power. 100,000 divided by 5,000, I like to just do this to make things a little nicer, is just 20. So 20, so I just reduce that down if I can. And then that equals this. All right, so this is where the logarithms come in. And we just need to write those letters log. If you look on your calculator, if you got a TI 30 something, or any related model to the TI 30, over on the left underneath the second you should see an log button, log. If you're using Desmos, you just have to type in log and it'll know what you want. And I'll show how to do this in Desmos here in a second. But you got log of 20, so you put a log on that side and you put a log on the other side. Whatever you do to one side of an equation, you do to the other. It doesn't change with logs. So you got this log on either side. Now this is why we're using this, and it's the only way we're really going to use these things in this class. You only need to know this one thing about logs in this class. Because we have a power there in what's called the argument to the log, we can bring it out front and multiply by what's left, the log of 1.37. And now I can divide both sides by the log of 1.37, and I will get t. So I'm going to show you this in Desmos in a second, but one thing I want you to understand, this is a function. It's a log of something. And we can't just cancel the logs. It's not log times 20, log times 1.37. That's not what this means. So you can't just cancel out the logs. You can't divide 20 by 1.37 and make that one log of one number. Doesn't work that way. The log properties are very specific. You have to do two separate logs. Log of 20 divided by log of 1.37. So let's go ahead and see that in Desmos so you understand how that works and how to type it in. Okay, so let me get rid of this stuff from before here. So we're just going to do log, and then notice it starts out all weird, and then it's like, as soon as you put the g in there, it's like, oh yeah, the log, I know that. And then you put 20 in there, and now it already tells you what log of 20 is, but then you do division, and then you can type in just log of 1.37. And now it gives you this answer. So this is how you have to type it in. There's no simplification that you can do with this form any more than what's already there. So just, get used to it, type it in, and you get this 9.51, etc. And we're going to go ahead and just round to the tenths. So we'll get 9.5. So back over here then, we will get 9.5 equals t. And this was in terms of years, it was a yearly growth rate. So we would get 9.5 years. All right, if you have questions about this, which I completely understand if you do, you're seeing this new thing, the logs, but just know that we're going to use them in only this one context to move the power down to the front. And you introduce the logs after you have gotten the parentheses with that power alone on one side. And then you can divide it out and get your t alone. Okay, if you have questions, please ask. Otherwise, I hope you are having a great day.